Welcome everyone who just joined to Data Plus Room 2. We're very happy to have Data Plus Team 6, which is the Rural Electrification Project. From my perspective, this is a really fascinating mix of kind of history and text mining and data science and all sorts of very cool stuff. The format we're going to follow, probably familiar to you from the other rooms, is this group's going to present for about 5 minutes. And then let's just keep it open and casual like any poster session. We're just having it be virtual. So please don't hesitate at all to ask questions in the chat. Once the presentation is over, please don't hesitate to unmute yourself and just ask directly. And I'll ask a few questions if there aren't any from the audience. So go ahead and take it away, please.
So thank you everybody for stopping by our presentation. We are the Rural Electrification Project Group. My name is Franco.
My name is Tree.
My name is Juhao.
And so we'll be talking about what we were investigating throughout this program. So, so to start some background, in the early 1930s, the US was in the midst of the Great Depression, a time when many social programs were being implemented to combat the economic recession. And being that in 1935, just 10% of rural farms were electrified, the federal government established the Rural Electrification Administration, or REA, to increase farm output, create jobs, and improve rural living standards, with the hope that this increase in productivity might also help pull the country out of the recession. And so although the REA's primary function was to provide low interest loans for farmers to set up local electric cooperatives, it also ran the Electric Farm Equipment Roadshow from 1939 to 1941. And so that's been the focus of this project, is to see and essentially answer this question: did the Electric Farm Equipment Roadshow lead to local increases in rural electricity consumption?
So to answer this question, we script the historical document provided by REA and also the Federal Power Commission. So since the historical document may be damaged, we first use some image processing techniques to clean the document to recognize the level, so that we can use some R or Python package to script the data. And then we clean up it using some data transformation package. And the most tedious but most important part of our work is manually checking the accuracy of data, because in that we can have reliable data for our analysis. So we have 4 data sets so far. The first data is on the macro level. So it provides information about the production of electric energy and capacity for each state. And the second and third data set is on the company level. The second data set is for all the US electric utilities, but we only script the 1941 so far. And the main data set is the REA Annual Statistic Report. It provides comprehensive information about the REA barriers from 41 to 46. And the fourth data set is county level US census data. We hope that this can provide some demographic and agriculture data for our analysis. And it is open source data. You can download it from website. And so based on our data set, we create a Shiny app to help our others interactively explore our data site. So we provide a link here. I may share it after this talk, and you can open it and try to explore the data.
Yeah, so I already shared a link to a Shiny app if you guys want to explore that. And so now we've thought about the method that we're using. So given the Electric Farm Equipment Roadshow stop were deliberately and strategically planned and not randomized, our analysis necessitates the use of special methods to demonstrate the roadshow causal effect on rural electrification. So in order to isolate this effect, we use covariate and propensity scores matching techniques to replicate a randomized control trial. So in a covariate matching, we pair treatment and then control observations that have the most similar observable characteristic in covariates. And in the propensity score matching, we take this one step further and we're calculating the likelihood of a site experience treatment. And so we match that based on a propensity score.
So now moving to the results that we produced. So we found that yes, our covariate or the answer to the question that we initially posed is yes. The electric farm equipment roadshow did lead to local increases in rural electricity consumption. Our covariate match analysis showed that there was a yearly increase of about 64 kilowatt hours per residential customer surrounding sites that were treated or that did have a roadshow stop nearby. And we defined treatment to be having a roadshow stop within 20 miles of the site, just because given the time, we felt that 20 miles was a reasonable distance to travel for something like this, given that cars were, automobiles weren't necessarily as advanced and not as widespread as they are now. So our propensity score analysis also indicated that that the roadshow led to a 90 kilowatt hour increase in yearly consumption.
Except we want to know the marginal effect, we also want to know the trajectory of roadshow effect. So in the two picture on the right, you can see that as the time going on, the roadshow effect levels off and disappears in about 4 years. And also the cumulative effect picture shows that although the effect increase, but it levels off in about 4 years. So we can conclude that the roadshow effect is a short-term effect, and it will disappear in about 3 to 4 years.
Yeah, so our next step would be refining our analysis and producing a technical write-up to have it published in a journal or publication. We also hope to extend our findings to explore present-day applications of similar approaches to rural electrification. So does anyone have any questions?
Thank you. Really nice. And I have to say, it really resonates with me to hear the most tedious thing being the most important thing. That defines data science pretty much entirely. There's a couple questions in the chat already. Xiao Chen asks, could you elaborate on the concept between covariate and propensity score matching?
I can answer that very quickly. So for the covariate matching, so imagine like each point is a vector, which you may fill that vector with information you need. For example, we fill it with miles energized, we fill it with state, number of state, zip code, something like that. So you have a vector that fill with all the information you need. And so every data is a vector, and you will split those data in a control and treatment group. And so you would take one data from one point from the control group, and you will compare the distance of that point to every point in the treatment group, in the other group. And so you would use, so our method, we use the nearest neighbor matching. So we calculate all of that, values, and we choose which point from the other group has the smallest distance, and we'll consider them a match. So we'll match every point from the treatment group with the control group, and the point that left over in the control group we won't consider them in our analysis, because they will kind of distort our analysis. So after doing that thing, we essentially have a two same populations in the control and treatment group, and it make it easier to do some analysis on based on that. For propensity score matching, we do the similar thing. We fit every variable we want to consider into a probit or a logit regression, and so it will generate a propensity score for each data, and then we'll match based on that, based on the nearest neighbor matching. So if the data in a control and if a propensity score in a treatment group is similar to a propensity score in a control group, we'll call that a match, and we'll do that essentially same technique.
Yeah, just to add to what Tree is saying, so for propensity score matching, essentially we're taking, since it's a probit or a logit regression model that we're fitting, the output or the response variable is going to be between 0 and 1, so it's a probability. So essentially you can view the propensity score as a probability of experiencing treatment based on the observable characteristics that we have for each point. So propensity score matching is essentially matching control and treatment observations based on their likelihood of experiencing treatment. So you match 2 points from opposite populations based on how likely they are to experience treatment, whereas covariate, we're not necessarily calculating how likely they are to experience treatment. We're just comparing their observable characteristics and matching based on that. So like say, match 2 points that have very similar demographic information, like have the same number of miles of farm, like surface area of farmland, and the same number of farms and the same output, farm output, the same pre-existing number of miles energized, or number of miles of distribution line already set up, things like that.
Yeah, sorry, I'm not stats major. I just wanted to clarify, what do you mean by the control and treatment? So the treatment, like how do you separate these two groups?
Yeah, so control and treatment for the sake of our analysis is just, was there a stop, a roadshow stop within 20 miles of the site in question, essentially. And so if there was, it's considered a treated site. If there was not, then it's considered a control site. And we can easily, this isn't like an arbitrary cutoff. We can just change that and redo the analyses, but we ultimately decided the 20-mile cutoff seemed like a reasonable cutoff for where the effect might be greatest within those 20 miles.
Awesome, thanks.
Either Jose M or Jose M, I can't quite tell. Can you just unmute yourself and ask your question? Because I think you edited it a few times. Or maybe you've left. Let's see.
Sorry, Paul. Yeah. Could you repeat the question?
So you put a question in the chat, but why don't you just unmute yourself and ask? Because I think you had a few more observations as you went.
Yeah, my question was regarding when using propensity score. One, I think I want to clarify whether there is an issue with unbalancing the data, because if you have one period of time of observations higher than the between treatment and observation group, maybe you induce some bias because you're going to be, for the propensity score, using many times one part of the data set. I don't know if that's clear, my question, when you have imbalanced data in order to create that propensity score. That's one question. And the second was, for the covariate analysis, I understand that's something similar to stratify based on one or some features. So, for example, you have old and young people, then you compare, not creating a score, but just using different stratus. Those are two of my questions. And thank you for the presentation. It's really good. Do you hear me?
I think, yeah. I think, I don't know, Jiha or Tree, you guys want to take the question about checking for balance?
Yeah, actually, we check the balance property before and after the propensity score matching. So since the poster is the space is limited, we do not put those balance check result on the poster. But maybe I can share you our
Yeah, I just want to
yeah.
add that real quick. So for checking the balance, what we essentially do is we calculate for, so we consider like different variables for our analysis. For example, we consider miles energized, we consider like, a lot of variables. And what we want to do in those variables before we do some matching is we calculate the mean, standardized mean difference in those variable. And so before the analysis, those were really off balance, but after the analysis, we've graphed that, we've plot that balance, and they all fall into like a small, they all fall into a very small imbalance. So I would say they, after the propensity score matching, they are not really a lot of bias cause or like imbalance.
Yeah, so you can say this is the balance property check after the Borrier year level matching. So you can say after the matching, the p-value is all bigger than 0.1. So this point that there is no significant difference between the treatment and control group for each covariate we select. And also the standard bias is less than 5%. The 5% threshold is put by some literature. So if it's less than 5%, there will be no significant difference between the treatment and control group. So from these two indicators, we can conclude that there is no significant difference, and the balance property is met after the matching. Yeah.
I take it you all are writing a substantial report in addition to this poster session, which is what we're looking at now.
Yeah, this is just a report when we have a meeting with our leader. So
excellent.
Yeah, we have some results.
So this is t-test, something similar to a t-test, right? Or it's a regression. The report I'm seeing now.
Sorry.
So other questions folks have? So I have a generic question I ask every room when there's a bit of silence, which is, you had a whole bunch of technical stuff going on here. Is there anything you didn't know how to do before your program started, and what was it, and how do you feel about it now?
Oh, for me, I had very limited experience, or actually no experience whatsoever using R. And R, turns out, is a very powerful language, and not the easiest, I didn't think it was the most intuitive to learn, having no experience, but I definitely feel a lot more comfortable with it now, and I think that was, I I definitely can see myself using it in the future. So I think that was a really valuable experience throughout this.
So yeah, for me, since I'm also an economics student, I have limited experience about R, but I make the Shiny app, so I saw the power of R language, and it's very easy to use for creating such an interactive map. So yeah, I think it's a great way to make our data public and help users to explore our data set. Yeah.
And I should say, by the way, assuming your leads are comfortable with the app being public and you are, when you send the poster to Ariel, just send a link to the app as well, and she'll include that on the website for the summary website for the project. So it's up to you all if you feel like it's ready to be slammed with lots of viewers yet or not. But so one question, and this is far-reaching. Seems like what you're doing here is the interesting thing of you have a historical government intervention or a government program, and you're trying to sort of actually measure an effect. The New Deal had a large number of government programs, interventions, and things like this. Do you think the kind of stuff you're doing would map over well to any one of them in particular? That may be asking you to know too much about history, but how portable over is this kind of methodology and analysis to other New Deal programs or other historical government programs?
Sure. Well, the propensity score analysis that we performed in this project is pretty applicable to other, I think, programs in a similar time period, just because more generally, it allows you to take observational data and replicate a sort of randomized environment. So it really is especially useful for historical data like this. So I'm not sure which other programs were taking place at the time. Unfortunately, I don't have that sort of historical knowledge, but I definitely think that it could be useful in other sorts of analyses from that time period.
Cool. So we've got about 5-6 minutes left till the transition time to the next one. Any other folks have questions? Unmute yourself or put them in the chat.
We can also, I don't know, Jihad, do you want to show a little bit of the Shiny app now? If there aren't any other questions.
That'd be great.
Yeah, I can. Yeah, this is the interactive map part of our Shiny app. So you can see the point means each REA barrier. So we separate the color of the point by if they are treated barrier. So if yes, it is painted as green. If it's no, it's painted red. So you can see most of the size is non-treatment, so control group. So the main variable in our map is the growth rate of energy consumption or growth of miles energized. So you can select which year, which range of the year you want to see. So that by default we set it from 41 to 46. So the size of the point is determined by the growth rate of energy consumption. So if they have a larger growth rate. So the point size is larger. And if you click a specific point, you can see which system, the system name, and also which city, which county and state they locate, and also the specific data about this system. And also we, so depend on your the bound of the map, you can depict the change of energy consumption, their distribution. So if you zoom in, these two graphs will also change by by your point in your map bound. And also you can change the distance threshold by defining the treatment group. So by default, we use 20 miles as our threshold to define the treatment group. And also you can change it to 30 miles. So there will be more green points, so more treated points. And also we have created a data explorer tab. So you can change the data year you want to see. By default, it's 41 to 46. And here is the data set selected by your criteria. Here, you can select specific states you want to see. Maybe you can select Alabama. So it only shows the system in Alabama state. And also you can select the counties within the Alabama and also the specific system you want to see. And also you can download the selected data you use this criteria. And also there is a README tab. So it's acknowledgement for our project leader and manager. And also we provide a link here so you can download our data from the GitHub page. So this is our data set and we make it public. So if you are interested, you can download it. And also the Shiny app code to create the app is also here. So if you are interested, you can download it. Yeah. Yeah, that's all.
Thank you. That's very impressive. I think almost any project can use a Shiny app, and I think this really helps tell the story. Just want to flag for folks that if you're wanting to be somewhere else for the 11:30, it's 11:26 now. You may want to hop over there. Otherwise, let's have this group. Well, this group's already unshared its screen. If from the Blue Devil group could share theirs, we'll get that set up. And I want to thank the Rural Electrification group for really awesome work this summer.